Very good morning to all of you. Today I want to start experiment number 17. Title of experiment number 17 is determination of conductivity of the given sample. Based on the experiment number 17 title and environmental engineering laboratory lab, there are some course outcomes are arrived. Here 4 course outcomes are there. One is acquire capability to conduct experiments and estimate the concentration of different parameters. Compare the result with standards and discuss based on the purpose of analysis. Determine type of treatment, degree of treatment for water and wastewater. Next course outcome is identify the parameter to be analyzed for the student project work in environmental stream. So these are the 4 course outcomes are prepared based on these subjects of all the experiments. Title of subject is Environmental Engineering Laboratory and the subject code is 18CVL67. This comes in 6th semester of civil engineering department or branch. These are the apparatus or instruments are regularly used for environmental engineering experiments. If you want to conduct any experiments of the given titles, you use these apparatus. Okay, so that's why you should be remember first apparatus and equipments names. Now let us see background of conductivity or basic concept of conductivity. Conductivity is numerical expression of the ability of an aqueous solution to carry an electric current. Conductivity is a numerical expression of the ability of an aqueous solution to carry an electric current. This ability depends on the presence of ions, their total concentration, mobility, valence and relative concentrations, and on the temperature of measurement. Solutions of most inorganic acids, bases and salts are relatively good conductors. Solutions of most inorganic acids, bases and salts are relatively good conductors. The unit of conductance is the micro ohm or reciprocal ohm micron. Specific conductivity is the conductance at a specified temperature across a column of a liquid 1 centimeter square in area and 1 centimeter long, and is expressed in micromores per centimeters. Micromores per centimeters. This is an inconveniently large unit for water testing, and it is usual to use the micromore per centimeter known as the Dynamic unit, which is 1/1,000,000th part of a micromole per centimeters. This is the basic concept and unit about the conductivity. Now let us, which are the apparatus are required to conduct this experiment. Cyber scan conductivity meter is required, beaker is required, pipette is required, etc. So these are the apparatus and instruments are required to execute this given experiment. Now reagent is required. Which reagent is required to conduct this experiment? 0.01 normality KCl solution is required. 0.01 normality KCl solution is prepared based on following steps. Dissolve 0.746 grams of potassium chloride in 1 liter of distilled water. Okay, dissolve 0.746 gram of potassium chloride in 1 liter of distilled water and it dilute completely. So now the conductivity should be 1413 micromole at 25 degree centigrade temperature. So this is the standard KCl solution is prepared. Procedure: how to execute this experiment by using conductivity instrument. First step is switch on the instrument by pressing on off key. The full LCD lights up for a few seconds to display all segments as a self-diagnostic test of the LCD. Then the meter will display the conductivity measurement. The next step, rinse the electrode thoroughly with deionized water, that is in distilled water. Rinse the electrode thoroughly with deionized water, that is called double distilled water. Note that mode is in conductivity mode. Immerse the electrode into the selected standard solution, that is 1413 micromoles per centimeter and press calibration mode key. Now the primary display shows the measured reading while the secondary display indicates the temperature of calibration solution. Okay, I will repeat once again. Immerse the electrode into the selected standard solutions, that is 1413 micromoles per centimeter, and press calibration knob. Now the primary display shows the measured reading while the secondary display indicates the temperature of calibrating solution. So this step is most important. Use MI up or down key to scroll to the correct standard solution value on the meters, means you adjust to required readings. Press enter to confirm the calibration value. The program will resume to its measurement mode. Okay, press enter to confirm the calibration value, then the program will resume to its measurement mode. Immerse the electrode in the given sample and note down the conductivity value. Now write the results. You take two samples, that is conductivity of sample number 1 is in micromoles per centimeter and conductivity of sample number 2 is some value and we are expressed in terms of micromoles per centimeters. Then write the conclusion based on the results. Now these are the references are referred, that is some IS codes of series 2025 and standard method of examination of water and wastewater by AFA 20th editions, and this textbook, that is Clay, Xavier and Perry, McCarthy and Jeannie Parkin, that is Chemistry for Environmental Engineering and Science Micro Hill series in Civil and Environmental Engineering. So these are the references are referred for to execute these experiments. Thank you one and all. Next experiment I will be continue in next class.